So here given three complex numbers z1, z2 and origin are the vertices of an equilateral triangle. Then the value of z1 square plus z2 square minus z1 z2 is how much? So if we know that if z1, z2 and z3 are the three complex numbers as the vertices of equilateral triangle, then we have z1 square plus z2 square plus z3 square is equal to z1 into z2 plus z2 into z3 plus z3 into z1. So here we can say the three complex numbers are here z1, z2 and origin. So we can write z1 square plus z2 square plus 0 square is equal to z1 z2 plus z2 into 0 plus 0 into z3. So we can say z1 square plus z2 square is equal to z1 z2, or we can write z1 square plus z2 square minus z1 z2 is equal to 0. So we can go with an option A. Given one universal set containing the roots of the fifth degree equation and subsets A and B, where A is a set of roots of the second degree equation, x square minus 5x plus 6 is equal to 0, and set B is also containing the roots of the equation x square minus 3x plus 2 is equal to 0. And then we need to find the complement of A intersection B. So let's find the roots of A and B, or let's find the set A and B. X square minus 5x plus 6 we can simplify, minus 3x minus 2x plus 6 is equal to 0. So that is x minus 3 into x minus 2 we can write. So we got the values x is equal to 3 and 2. So set A is equal to 2 and 3. And now the set B, we can write x square minus 2x minus x plus 2, or we can write x minus 2 into x minus 1 is equal to 0. So we can define the set B is equal to set containing 1 and 2. So we got A is equal to 2 and 3 and B is equal to 1 and 2, and since U is a universal set, so surely we can say that A is a subset of universal set and B is also subset of universal set, and hence we can conclude that 1 comma 2 comma 3 are the, we can say 1 comma 2 comma 3 must be the solution of the fifth degree equation. And also x to the power of 5 minus 6x power 4 plus 11x to the power of 3 minus 6x square is equal to 0. Clearly we can say that x square is 0. So here x square we can write x power 3 minus 6x square plus 11x minus 6 is equal to 0. So we can, two repeated roots are there, x is equal to 0, and the next cubic equation where we can also check that 1 is a root. So 1 minus 6 plus 11 minus 6 which is equal to 0. So by using the synthetic division method, taking the coefficients, we can write 1, negative 6 plus 11 and minus 6, and now testing with 1 for x is equal to 1, you must get the remainder 0. So here 1 plus 0 is 1, 1 ones are 1, and again minus 6 plus 1 is negative 5, 1 into negative 5 is minus 5. So 11 minus 5 is 6, 1 into 6 is 6, so minus 6 plus 6 is 0. So if we're getting the remainder 0 means we can consider x minus 1 is a factor. And again we have 2 also, so let us check with 2. So we can consider 2 here, start with 0, 1 plus 0 is 1, 2 ones are 2, minus 5 plus 2 is negative 3, and 2 into minus 3 is minus 6, so it is 0 again, so the remainder is 0. So we can consider that x is equal to 2 is also a factor. And last we have x minus 3. So we can write this as x square into x minus 1 into x minus 2 into x minus 3 is equal to 0. So universal set is containing 0, 1, 2 and 3. And now we want A intersection B. A intersection B is equal to 2 comma 3 and 1 comma 2, only we have 2, and then A intersection B whole complement is equal to mu minus universal set minus of A intersection B. So universal set is here 0, 1, 2, 3, from 0 comma 1 comma 2 comma 3 minus, and the set A intersection B is 2, so we'll be getting the answer as 0, 1 and 3. So 0, 1 and 3 is, which is option is C. Option C is the answer. Given complex number z is equal to x plus iy and z power 1 by 3 is equal to a minus ib. Let's cubing on both sides. So we get z is equal to a minus ib whole to the power 3. And we know that a minus b whole cube is equal to a cube minus b cube minus 3a square b plus 3ab square. So let us simplify here. Z is equal to a to the power of 3 minus ib whole cube minus 3 into a square into ib plus 3ab square. So 3 into a into ib whole square. So we can add a to the power of 3 minus, and we know I square is equal to minus 1 and I power 3 is equal to minus I. So we can add minus of minus plus I into b cube, and again here minus 3 a square b into I plus 3a into I square value is negative 1. So we can write here minus 3a b square, or we can also write a to the power of 3 minus 3ab square real part, and imaginary part I can write b power 3 minus 3a square b, and this can also be written a times of a square minus 3b square plus I into b times of b square minus 3a square. And now let's, z is equal to x plus iy is given, comparing with the real part and imaginary parts. So we get x is equal to a times of a square minus 3b square, that is x upon a is equal to a square minus 3b square. Similarly, y is equal to, so y is equal to b times of b square minus 3a square, or y upon b is equal to b square minus 3a square. Now x upon a minus y upon b is equal to, so from 1 and 2, so we can write a square minus 3b square minus of b square minus 3a square, which is equal to a square minus 3b square minus b square, and again plus 3a square, that is 4 times of a square minus b square. So in comparing with k times of a square minus b square, so we can say k is equal to 4. So we can go with an option D. I to the power 57 plus 1 upon I to the power 25. So here I is the square root of negative 1, and we have I to the power of 4n is equal to 1, I to the power of 4n plus 1 is equal to I to the power 4n plus 2 is equal to I square, which is equal to negative 1, and I to the power of 4n plus 3 is equal to I to the power of 3, which is negative I. So when 57 is divided with 4, so 57 we can write it as 4 into 14 plus 1. So which is in the form I to the power of 4n plus 1. So I to the power of 57 we can write I to the power of 1. And similarly, I to the power of 25, we can write I to the power of 4 6 are 24 plus 1, again the same I to the power 1. And also we know that 1 upon I is equal to negative I. So we can write I to the power of 57 plus 1 upon I to the power of 25 is equal to I to the power 1 plus 1 upon I. And 1 upon I is negative I, so I minus I, which is equal to 0. So we can go with an option 0, option A. The complex number z is equal to x plus iy, which satisfies the equation mod of z minus 3i upon z plus 3i is equal to 1 lies on, whether it is on x-axis or on the straight line y is equal to 3, or it is a circle passing through origin, or none of this. So let us simplify this. Mod of z minus 3i upon mod of z plus 3i is equal to 1. Since we know that mod of z1 by z2 is equal to mod z1 upon mod z2. So here we can write mod of z minus 3i is equal to mod of z plus 3i, and z minus of 0 plus 3i, which is equal to mod of z minus of 0 minus 3i. We can write like this. So there is one complex number. So there is a complex number z such a way that the distance from 0 comma 3, you can mark the point 0 comma 3, the positive direction of y-axis, and next 0 comma minus 3, the negative direction of y-axis. So the complex number z, which is satisfying the condition in such a way that the distance between these 2 points is always same. So we know that the locus of z, which is equidistant between these 2 points, is the perpendicular bisector. So the perpendicular bisector of these 2 points is x-axis. Perpendicular bisector, we can write here. Perpendicular bisector of line joining 0 comma 3 and 0 comma minus 3 is x-axis. So therefore we can conclude that the z lies on x-axis. So we can go with an option A. Given a quadratic equation x square minus x plus 1 equals to 0, and whose roots are alpha and beta set, then we need to find the equation whose roots are alpha power 100 and beta power 100. So first of all we should understand x power 3 plus 1 is equal to x plus 1 into x square minus x plus 1. So here minus 1 and minus omega square are the roots for the equation x power 3 plus 1 equals to 0. And similarly, x power 3 minus 1 is equal to, we can write x minus 1 into x square plus x plus 1. So here we can say that x is equal to 1, and here we can consider omega and omega square. So omega and omega square and 1 are the roots of the equation x power 3 minus 1 equals to 0, and here we can say for x power 3 plus 1 equals to 0. So since x square minus x plus 1 equals to 0, so the complex roots can be considered minus omega and minus omega square. Say alpha is equal to minus omega and beta is equal to minus omega square. So alpha power 100 is equal to minus omega power 100, which is equal to omega power 100. That is omega, when 100 is divided with 3, so 3 into 33 plus 1, so the remainder is 1. Since omega cube is 1, so we can write which is equal to omega power 1. And similarly now beta power 100 is equal to minus omega square whole power 100, which is equal to omega power 200. And when 200 is divided with 3, so we can write 3 how many times? 3 6 are 18, and again here 3 6 are 18 plus 2. So which is equal to omega square, we can write. Now omega and omega square are the roots for the new equation. Since we have already seen omega and omega square are the roots, are the complex roots for the equation x square plus x plus 1 equals to 0. So we can conclude that omega and omega square, that is alpha power 100 and beta power 100, are the roots of x square plus x plus 1 equals to 0. So we can go with an option D. We need to find the amplitude of a complex number sin pi by 5 plus I times of 1 minus cos pi by 5. First let us simplify this complex number in the form of a plus ib. So sin pi by 5 we can write it as sin theta is equal to 2 sin theta by 2 and cos theta by 2, and also 1 minus cos theta we can write 2 sin square theta by 2. So we can write here 2 sin pi by 10 into cos pi by 10 plus I times of 2 sin square theta by 2, that is pi by 10. So I can take 2 sin pi by 10 common. So I can write cos pi by 10 plus I sin pi by 10. So that is 2 sin pi by 10 into e to the power of I pi by 10. Since we know that e power I theta is equal to cos theta plus I sin theta, where theta is the amplitude. So we can consider that pi by 10 is the amplitude. Or can also be written this complex number in the form of a plus ib, and if theta is the amplitude, then we have tan theta is equal to b upon a. So we can write tan theta is equal to b sin pi by 10 upon a is cos pi by 10. So tan theta is equal to tan pi by 10. So which implies theta is equal to pi by 10. So we can also get the solution in this way. So anyhow the answer is pi by 10, option C. Given x in terms of omega, that is complex cube root of unity, and then the value of x power 4 plus 3x power 3 plus 2x square minus 11x minus 6 is, let us recall the properties. Omega cube is equal to 1 and 1 plus omega square is equal to 0. Given x is equal to omega minus omega square minus 2, so this can also be written x plus 2 is equal to omega minus omega square, or squaring on both sides you can write omega square plus omega power 4 minus 2 times of omega power 3, that is x square plus 4x plus 4 is equal to omega square, and omega power 4 we can write it as omega power 3 into omega minus 2 into omega cube. Since omega cube is 1, so we can write x square plus 4x plus 4, that is omega square plus 1 into omega is omega minus 2. And since we know omega plus omega square is equal to negative 1, so we can write here negative 1 minus 2. So x square plus 4x plus 4 is equal to negative 3. X square plus 4x plus 4 and here plus 3 is equal to 0, or we can write x square plus 4x plus 7 is equal to 0. So with this condition, For x is equal to omega minus omega square minus 2, we got the condition x square plus 4x plus 7 is equal to 0. So let's divide. Let's divide the given polynomial x power 4 plus 3x power 3 plus 2x square minus 11x minus 6 with x square plus 4x plus 7 so that we can find the quotient. So let's write x power 4 plus 3x power 3 plus 2x square minus 11x minus 6 divided with x square plus 4x plus 7. So we can write x square, how many times x square is x power 2. So x square into x square is x power 4. 4x into x square is 4x power 3 and plus 7x square. Subtraction. So 3 minus 4 minus x cube and again here minus 5x square minus 11x. Now we can consider x square minus x times we will get minus x cube. So let us take minus x. So minus x is multiplied. So minus x power 3 minus 4x square and minus 7x. So we can get here minus 5 plus 4 is negative x square and again here minus x is minus 11 plus 7 is minus 4x and again minus 6. Now here x square minus 1 times you will get negative x square. So let us take minus 1 here. So minus 1 is multiplied here minus x square minus 4x and minus 7. So you will be getting, so minus of minus plus here x square get cancelled and here also minus 4x plus 4x get cancelled and again here minus 6 plus 7 is 1. So finally we can say that this polynomial x power 4 plus 3x cube plus 2x square minus 11x minus 6 is equal to x square plus 4x plus 7 into x square minus x minus 7 plus the remainder is 1. And we know that x square plus 4x plus 7 value is 0. So 0 into x square minus x minus 1 plus 1, that is 1. So we can go with an option A. Given here z is equal to a plus 2i, where a is positive and real number and z into mod z minus az plus 1 equals to 0 is satisfying. So that we need to find out among the four options which is correct. So let us consider, or let us substitute z is equal to a plus 2i. Substitute in the equation z into mod z minus az plus 1 is equal to 0. So here we can write mod z is equal to under root of a square plus 2 square, that is root of a square plus 4. So we can write a plus 2i into root of a square plus 4 minus a times of a plus 2i plus 1 equals to 0. Or we can write a times root of a square plus 4 plus 2i times root of a square plus 4 minus a square minus 2ai plus 1 equals to 0. Now separating the real terms and imaginary terms. So we can write a root of a square plus 4 minus a square plus 1 is a real part and imaginary part we can write 2 root of a square plus 4 minus 2a is equal to 0. So here real part and this is imaginary part which is equal to 0. So we can write 0, we can write it as 0 plus 0i. So consider real part a root of, let us consider the imaginary part. So 2 root of a square plus 4 minus 2a is equal to 0, or we can write root of a square plus 4 is equal to a, or squaring on both sides we can write a square plus 4 is equal to a square. So when a square plus 4 is equal to a square, it is not at all possible for any real number, because for any real number, for a greater than 0, a square is greater than 0 and a square plus 4 must be greater than or equals to 4. But here a square plus 4 cannot be equal to a square, so we can conclude that there is no complex number satisfies this condition. No complex number exists. So we can go with an option D. So we need to find the nature of the roots of the equation. X square minus 2 root 2x plus 1 is equal to 0. And first thing we need to observe that the coefficients are here not rational numbers, they are irrational numbers. 2 root 2 is an irrational number. Now let's find discriminant. When comparing with ax square plus bx plus c equals to 0, the discriminant is b square minus 4ac, which is equal to minus 2 root 2 whole square minus 4 into 1 into 1, that is 2 2s are 4 2s are 8 minus 4, which is equal to 4. It's a perfect square number. Even though it is a perfect square number, but since the coefficients a, b, c are not all rational numbers, and hence we cannot tell that the given roots are rational and different. Since delta is greater than 0, we can come to the conclusion their roots are real and different. And since the coefficients are not all rational numbers, we cannot say it is a perfect square number, and hence we cannot say it they are rational. So option D cannot be taken. So we can consider the real and different. The option A can be taken. So option A is the answer. And even we can find the roots. X is equal to minus b plus or minus under root of b square minus 4ac divided by 2a. So when we are doing it, minus b, that is 2 root 2x, 2 root 2 plus or minus, and here the root of 4, that is 2 divided by 2 into 1 2. So we can write root 2 plus or minus 1. So here we can say that one root is root 2 plus 1 and another root is root 2 minus 1. They are not rational, they are irrational numbers. So real and different.